So first things first, let's say if A vector is equal to AX I cap plus AY J cap.
Mm-hmm.
What is the value of tan theta?
Tan theta would be like y over like ay over ax.
So whatever it is in the J component upon
Mm-hmm.
X.
Upon that.
So if you know tan theta value is this much, what will be the value of cos theta?
Cos theta would be the r, and then it would be the ax component. And then
Okay.
this, wait, sorry, no, sorry. It would be r, and then, yeah, the ax component.
Okay. How do you write that? Can you write it?
Mm-hmm.
There is a tools icon on the left.
Yeah.
Yeah. So I'm talking about this vector in specific. What is the value of cos theta?
It'd be the ax component, right? Ax component over
Yes.
r.
Ax upon r. What is r actually?
The hypotenuse.
Hypotenuse.
Mm-hmm.
So in terms of ax and ay, how can you write r?
Mm-hmm.
Okay. Vector will be,
So the magnitude of the vector.
yeah, magnitude of vector formula is
The like the square root, and then ax squared plus ay squared.
that is the thing. So cos theta will be equal to ax upon root of, right there, ax upon.
Mm-hmm.
So that is equal to
Mm-hmm.
ax upon root of square root of ax square plus.
Okay, yeah, okay. Yeah. Ax squared plus y.
Okay. Yeah, full root. So in this question specifically, it is capital AX and capital AY, but I think you understand the concept. Okay. So theta is this. So tan theta. So basically, one way to look at it is tan theta is this, right? So in trigonometry, you might have come across. Let's say sin theta is equal to, let's say, 1 by 5. Cos theta value will be how much? Tan theta value will be how much? It's a question based on trigonometry.
Mm-hmm.
So one way to do this is you consider a triangle, theta, right?
Yeah.
Opposite by,
Hypotenuse.
so 1 upon
5.
5. So 1 is here, and yeah, 5 is there.
Mm-hmm.
So can you find the adjacent side?
Pythagoras theorem to find it.
How much is this? Not with the calculator, okay? Do it with mine.
Yeah. So then you just do like 1 squared plus something equals 25.
Yeah, what is the answer for this? How much is that? Can you guess?
Distance would be scalar, right?
Yes.
Yeah, so the distance will just have the magnitude, and displacement will have magnitude and the direction.
Yeah.
So is it like with distance, is that the one where it's like gonna be always positive technically, or
Yes. So distance is the length. It is always positive.
mm-hmm.
Positive. Because we measure it.
Yeah.
Tape or something. It will be positive. Displacement can be negative because of direction. If you chose the coordinate axis, if you chose this direction as positive,
Yeah.
if you go like this, this distance will be obviously
Negative.
displacement can be negative.
Mm.
So can be negative. It usually depends on coordinate system.
So it depends which, like, what you define as positive. Like,
Yes.
is that the one where it's like based on like your observation or something? It said that in the notes, something like that, like based on your observation, like what you're observing it from, something like that. I don't know.
What was that?
Um, like where I guess yeah, it's the same thing that you said. Like whatever you determine as positive based on where you're observing from.
So whatever we are determining. So basically choosing the coordinate system.
Yeah.
So what is x and what is y? Which direction is positive? Like that.
Mm-hmm.
So where you are going to choose the origin.
Mm-hmm.
Things like that matter the most. So displacement can be negative. Okay. Let's say there is a person who is who is starting from this point, point A,
Mm-hmm.
east by 3 units, north by 4 units.
Mm-hmm.
Point B, point C. What is the distance? What is the displacement?
So distance that doesn't have direction, right? So would you just add it like 7 units?
Yes. Distance traveled is total distance. Like what is the
Mm.
original path? 3 plus 4.
Yeah.
What about the displacement? We know that it is a vector.
Vector quantity.
So displacement, to find displacement, what do we do is you mark 2 points. What 2 points? Initial point and final point. Where were you in the beginning and where was that person at the end? So in the beginning, where was the person?
At the origin.
At point A, right?
At point A.
So in between, he traveled up to B. But if I ask you, what is the final position? Where is the final position? Where did it stop?
North for the like point C north.
At, at point C,
Went
right?
up.
This is the final point.
Mm.
So I'm writing here I for initial, F for final. Any doubt?
Mm.
So yeah,
You
no doubt.
just yeah,
This is the
yeah,
vector.
you can just trace it.
So you join the initial with the final point. This is called displacement vector.
Displacement. Okay.
So initial point and final point, you need to mark them and then start from initial point towards the final.
Mm-hmm.
So AC is the displacement vector. How much is AC magnitude? Can you guess?
5.
5. Simple, right? 3, 4, 5 triangle. So this is 90 degrees. Because
Yeah.
north, south, east, west, there are like 90 degrees, 90 degrees. So that is what. That's it. So displacement is 5. Distance is 7, right?
Yeah.
So which one is bigger?
The distance.
Distance is bigger. Okay. Let's say if a person is moving along a straight line, let's say he was here, started at point A, he reached point B. He traveled, let's say, 5 meters. What is the distance and what is the displacement? How much?
So the person started at point A and then went 5 meters east to point B.
Yep. Straight line.
So distance would be 5 meters. Just
What
went
about the
straight.
displacement? How much will be its magnitude?
5 meters?
Same. 5, right? See,
Yeah.
the concept is still the same. You have to mark 2 points, initial and final.
Yeah, because they didn't change the direction or anything. They just went like a straight
Yes.
line.
So join initial like this. This is the vector.
Mm-hmm.
So 5. Clearly it is 5.
Yeah, so do you have to write like 5 for displacement? Do you have to write like 5 units east, and then for the previous one, do you write like northeast or no?
Okay. If you look carefully, I have written like this. What is this actually?
The magnitude of the vector?
Yeah, I have only specified the magnitude. So, do you remember 3, 4, 5 triangle will be how? What are the angles in that triangle?
90, 45, and 45.
No. 45, 45, 90 is for isosceles. When sides are equal. I told you like 37 degrees.
Oh, yeah, sorry. Yeah, 37, 53.
So which one is 37? Which one is 53? Is this 37 or is this 53?
37?
Well, it's like there is a theory in triangles. Like angles opposite to larger side is larger. This is 4.
Yeah.
But this is 3.
Mm-hmm.
Okay. For 4, opposite angle is this, right?
Yeah.
For 3, opposite angle is this.
Yeah.
So which side is bigger?
This side?
4 is 4. Side 4 is bigger.
Yeah.
So the angle opposite to that will be bigger.
Okay. So it's 57.
One way to look at it is the highest angle in this triangle is what?
90.
So 90 will be the so opposite side to the 90 is called hypotenuse. Hypotenuse is also known as longest side,
Longest side, yeah.
longest side. Okay,
Yeah.
makes sense, right? So this angle
Yeah.
will be how much?
53.
Okay, so 53 and 37. Okay,
Mm-hmm.
so what was the question again? Displacement. So magnitude we got in this question.
5 units.
Yeah. How do you represent the diagram direction?
East.
Vector is like this.
Yeah.
The angle made with horizontal theta will be how much?
53.
53 degrees. So you say the vector is 53 degrees. This is not, this is east, right? It is more tilted towards what?
East. Sorry. North. Okay. Sorry. North.
Okay. So north of east. Simple.
Okay. But then in the diagram, if it's just going straight, like how do how do you know?
Yeah. So you define a coordinate axis like this. Okay. So it's in what direction?
East.
Yeah. Or
Is in
yeah. If you want to write it in vector form, you can write like 5 I cap is the displacement vector. Any doubts over? 5 I cap. See, there are two notations. One is A vector versus A cap. What is the difference between these two?
Like the first one is like that whole vector, and the second one is a component of the vector.
Well, obviously, looking objectively, these arrow marks are different.
Yeah.
What does this mean? Means vector A. This means that unit vector. It's just like I cap, J cap. They are unit vectors.
Okay. Mm-hmm.
So magnitude of A cap will be 1. This is what you need to understand. It means that when cap is there, the magnitude will be 1. It is a unit vector.
Okay.
So other vectors like this can have magnitude of 2, 3, anything, right? So specifically speaking, for unit vectors, you have to represent them by cap. This is pronounced as cap. A cap,
Yeah.
I cap, J cap. And this is pronounced as
Yeah.
A bar or A vector or vector A. Same thing. Okay.
Mm-hmm.
Okay, the main point was you're comparing displacement and distance. So in this case, how much was the displacement value? Magnitude is how much?
5.
What about the distance?
5.
Is it greater? Distance is greater or less than displacement now? They are the same.
They're the same. Yeah.
So to generalize the concept, let's go to the next page. So the theory is distance is either always greater than displacement, magnitude of displacement, or sometimes it can also be equal. You know the symbol, right? Greater than
Yeah. Yeah.
or equal to.
Mm-hmm.
So this is one concept. So distance and displacement. This is the inequality. Hmm. And small things like, you know what is rest and what is motion?
Yeah.
Rest means
The object is not moving; it's stationary.
not moving. Motion means
Object is moving.
moving. MO is there, right?
Yeah.
So yeah. Okay, let's consider another example. Let's say a particle is traveling around a circle.
Mm-hmm.
It has reached its initial point from where it started with one full revolution
Yeah.
or rotation. Circle has a radius of 1 meter. What is the distance? What is the displacement?
So I know displacement would be 0 because it's back where it started. And then distance, I know one full revolution that'd be like it's gonna be 2 pi, but like
2 by r, right?
2 pi r. Yeah.
That's it.
So 2 pi.
I mean, that is the distance he covered, right?
Mm-hmm.
For one revolution means 2 pi r. Let's say for 2 revolutions,
4
Yeah, he has traveled twice.
Yeah.
So it's like n revolutions into 2 pi r length. N is equal to number of revolutions. Regardless of n, displacement will also always will be
0. Because it,
because initial and final points are coinciding. So this distance alone is singularity 0. Okay. Clear, right? No confusion so far?
yeah, it's clear.
Hmm. Okay. Let's say there is a vector here. The concept says that if you move this vector A, let's say like this, like this, like this, some anywhere,
Mm-hmm.
the vector doesn't change. It's the same vector.
Yeah.
Why is that? Because when you look at the definition of vector, what two things matter the most?
Magnitude and direction.
Magnitude. Magnitude can be defined by this length. If it is like this, it is small. If it is like this, it is
Big.
big. So magnitude is not changed. Any doubt?
Non doubt. Yeah, that makes sense.
So magnitude is not changed. But what about the direction it is pointing towards? Is it changing the direction? The direction, is it changing?
No, I mean it's still pointed like this. It's just in different places on the coordinate.
Yes, it is still pointing towards that direction only, right?
Yeah.
Magnitude not changing, direction also not changing. So can we say that, let's say this is B vector. A vector is same as
B.
B vector.
Mm.
Like if I give this vector another name, B vector, we objectively know that, and we know that A vector is B vector.
Yeah.
So basically, vector A doesn't change. Only thing matters is
Magnitude and direction.
yes. So this is one thing. That is why you can shift the vectors.
Mm-hmm.
Basically, translate the vectors. Translating means
Yeah.
you are moving along x or y, like horizontally or vertically, without rotating. Rotation is different.
Yeah. Rotation is different.
Yeah, that is why if there are, let's say, vectors like this, A vector and B vector, you might have seen in the short notes. What did we do with this B when you are trying to add?
Oh yeah, we split it into its x and y component.
Well, that is one way, but we have actually moved this onto the right side, like this.
Okay.
So that there will be an order. So the head of second vector matches with the tail of first vector.
I'm looking for vector. Yeah.
So the answer is, when you are adding A vector plus B vector, how do you represent the resultant?
Sorry, can you say that again?
When you are adding A with B,
Mm-hmm.
diagram, how do you represent that?
Like you would find its magnitude and direction, and then like represent it on the based on that.
Okay, can you draw it here? Where will be the resultant vector?
Would it just be here like that, or
Yeah. So two things: initial point, final point. When you are arranging like this order, so initial, join initial and final like this. Okay. So this is the resultant vector. R is equal to A bar plus B bar. Yeah, the concept we used was we have translated this B slightly towards right.
Yeah.
So yeah, and I think you know some basics, like let's say if this is A vector, minus A vector will be how?
It'd be the opposite way, so it'd be
Yes. And let's say this is A vector. Can you can you draw 2A vector and minus 2A
like
vector?
2A.
This is A vector, okay?
Yeah. So 2A would just be double, right?
Yes, draw that.
Pretend that's straight.
Yes. Yeah.
And then the other thing, like negative 2A will be the same, like as the double the length, but then the other way.
Yes, that's it. Okay. Okay, I think this is enough. Yeah, I can surely tell this is enough. It's just that there is one more topic, but it will be covered like in chapter 4 or 5. So no need to worry about that now. Okay. As far as chapter 1 is concerned, these are all the points which have been left from the previous class. Okay.
Okay.
Mm, yeah. Distance is equal to magnitude of displacement.
Yeah. Mhm.
Mm, yeah. See if displacement of A vector will be, let's say, minus 5 I cap, displacement will be 5 or negative 5. Its value, like quantity.
5, positive 5. Because
Quantity, yes.
because the negative in this case is just an observation, right? It's just telling you the direction, kind of like it's just telling you it's going the opposite way. It's not really.
Yes.
So you can just say like 5, like the displacement is 5 units, and then you, I guess, like say with the direct, like with the
Direction
angle, yeah, direction that would tell you like but it's going the other way.
or along negative x-axis. Okay. So the sign is used only for direction.
Direction.
So first point is, when it comes to motion along a straight line, distance is equal to displacement. You know how to identify distance, and you know how to draw displacement vector also. Initial points and final points like this.
Yeah.
So scroll down. So displacement vector, 2 points we need to mark, which is
Initial point and final.
where will be the tail and where will be the head.
It would just look like this, right? So then this is
Yes.
the
This is the tail end. This is the,
that's the tip.
yeah. I mean that's it. Okay. So distance, displacement. What is this there?
Speed or velocity.
Okay. Yeah. Second one is speed versus velocity. Difference is, I think we discussed.
Scalar velocities, a vector quantity will have direction and magnitude.
Yeah. Speed formula is
X over t, distance over time.
so distance traveled by time taken, right?
Yeah.
Formula for velocity is
Just take the derivative, right? That's how you roll it.
travel. So speed is distance traveled. Distance.
Mm-hmm.
Velocity means displacement upon time.
Yeah.
So dx upon dt.
Mm-hmm.
What does that mean is actually we need to understand what is mean by position vectors. Let's say there is a random point A. Its position vector will be you have to join with the origin like this. This is called position vector.
Yeah.
There is point B. Can you draw the position vector? Position vector for A. This is.
So do you go from A to B?
No. Position vector, specifically speaking, position vector means you have to join origin with the point. Yes. Origin with the required point.
Okay.
So origin is the head, point is the tail. Like that.
Yeah.
So this x in the displacement upon time is that difference of position vectors.
Mm-hmm.
It's like x final minus x initial. It's like let's say final initial point was here, final point was let's say after some random journey, it was here. This vector is actually xf minus xi.
Yeah. Final position minus initial position.
Yeah.
Yeah.
So this is this. So that is called displacement upon time. So dx by dt means rate of change of position vector
Yeah.
displacement. So basically another definition for displacement is rate of change of position vector. Hmm. So displacement is also called as change in position vector. So how much like from where to where you are changing, initial to final point. That is the thing. So now let's talk about acceleration.
Yeah.
Acceleration means it's a vector, okay?
Yeah.
Vector. The formula is d by dt of
Velocity.
velocity vector.
Velocity vector.
We also call it as change in velocity dv, right? Change in v upon time. So this is also called as rate of change in
Velocity.
velocity. See in physics, whenever you say rate of change, we assume that it is time rate of change. We don't write this time before, but it is an assumption.
Yeah.
So rate of change means d by dt. Obvious, we automatically assume that. Hmm. Speed, velocity, displacement, acceleration. Hmm.
Yeah. And then it's the instantaneous and average velocity, average and instantaneous acceleration. And then I think you just really you're relating it to the graphical representation or something.
Okay. Before that, let's talk about what is initial velocity and final velocity. Can you guess what it is?
So initial velocity is like usually always zero, right? Because that's where the object is at rest, and then the final velocity is like
Okay, let's say there is a car here, whatever.
yeah,
If it was not moving, it's at rest. Suddenly, if you turn on the engine, it starts moving. So from point A to point B, let's say point A is the initial point.
yeah,
Obviously, the velocity changes from 0 to something v.
yeah,
This is this is the story of point A to point B. But when I talk about, let's say there is another point in between, let's say point C. In between the journey, there is a point C. This is the same B. Here it was A. If you consider the time interval only between point C and B, is the initial velocity 0?
no,
No, right? For
yeah,
initial velocity, yes, because it is in motion. So initial velocity, don't always think that it is always 0.
yeah. I just heard you assume unless specified otherwise,
Yes.
right?
Uh,
And yeah,
it's hard to say, okay?
just what you're saying, yeah,
It depends on the situation.
yeah,
If if the question in the if the question describes a situation, if I drop an object from the building,
yeah,
drop means initial velocity is 0.
yeah,
Or if an object starts from rest, initial velocity is 0.
zero, yeah,
So dropping an object from a building. So V naught is 0.
yeah.
Starts from rest.
Rest.
Okay. What else? Or they say journey starts. Start the journey. Something like that. So these are some side points. The cases where initial velocity is 0. But obviously from C to B, between C to B, V naught is not 0.
Yeah.
So initial velocity means in the time interval which you are considering what is the starting velocity.
Yeah,
So V naught is the same as velocity at point C.
yeah.
So final velocity, can you guess no?
The velocity at point B.
Yes, velocity at point B. So velocity at end of journey.
Yeah. At the end of the journey.
Is represented as VF, V final.
Yeah.
Yeah, B at B. So clear, right?
Yeah.
So quickly write this. For this case, what is V0 and what is VF? Do you see this?
Yeah.
V0 is how much?
The
V0, V0.
we
See
just
now?
said it's at whatever it is at point C, right? Like
Okay, I'm talking about this scenario, this diagram. Journey has started from A.
then V naught would be zero.
Okay. Final will be at what point? V.
At
B.
point B.
That's it.
Maybe.
Hmm. And I think you are familiar with the units, meter per second.
Yeah.
What will be the units for displacement?
Meters.
Meters. What will be the units for acceleration?
Meters per second squared.
So meters per second. It's like dv by dt, right?
Yeah.
Velocity units are meter per second,
Meter per second. Yeah.
like this.
And then over seconds, so meters per second.
And acceleration means meter per second square. Okay. And do you know these things like how to divide the fractions? Let's say a by b by c versus a upon b by c.
Where did you write it?
Just beside this acceleration units. Scroll up.
Oh.
You see this? Yes. What is the difference between these two fractions? Yes, I think you know that. So basically, division means there will be a long symbol. Treat the other two as separate units. So here is the long symbol. So this is one unit, this is another unit. So a by bc. Here is the long fraction. So a upon b by c. So b by c becomes c by b. Just c becomes 1 by c. Okay. So that is why here meter per second square it is. Velocity has been divided with time. Okay. Can velocity be negative? Come to the next page.
Technically, yeah, but again, it's just showing the direction, right?
Yes. Negative means what? Direction. Can velocity be negative?
Yeah.
But can speed be negative?
No, because speed is scalar.
Yes. So yes, velocity can be negative, but speed
Cannot.
yeah, average and instantaneous. Let's get into that. Average versus instantaneous. See, average means you have to consider the overall journey. Okay, let's say do you watch cricket?
A little bit, yeah.
You know how many balls in an over?
No.
Okay, whatever. Okay, let's say let's say the price of $1 uh, is equal to 1.45 CAD, Canadian dollar.
Okay.
This price obviously will not be the same tomorrow. It can alter.
No.
It can become 1.44. Yes, it fluctuates. Price fluctuates. So average means if you consider in a specific interval, you say that let's say the price was 1.46 the other day. So on an average, the price was 1.44 on every day.
Yeah.
So that is called average. Instantaneous means we're talking about specific instant. So on specific date, this was this much. Another specific date.
This much. Yeah.
So instant means single point. Average means everything in mind. So same. If you want to add the suffix average speed versus instantaneous speed, or average velocity versus instantaneous velocity, they are the same thing. I mean the concept is the same. They are not same. Average velocity value is different from instantaneous velocity, but the concept which I discussed just now regarding average and instantaneous, these concepts are same.
Yeah.
Let's say a person starts from point A, he reaches point B by traveling a different weird route. What will be the displacement vector? Can you draw it?
Yeah. Okay. Will be from the initial point A to the final point B.
So this is displacement vector x bar of AB vector.
Yeah.
So along this direction, average velocity will also be there, because see, velocity formula is
dx over dt.
so it will be there in the same direction as
The displacement.
like this.
Yeah.
So average velocity, when you are considering the entire journey, its direction will be like this. Regarding instantaneous, you have to consider at only one specific point. So let's say a person is moving like this in this path, point A to point B. If you are okay, if you are talking about average velocity, it will be something like this in this direction. But if you are talking about only one specific point, this secant line becomes a tangent.
Yeah.
So remember dx by dt, right? Well, usually it is delta x upon delta t. If delta t approaches 0, delta t means what? Gap between initial and final.
Yeah.
Initial and final. So if this gap becomes smaller and smaller, it will approach a single point. So when delta t gap approaches 0, the velocity which we get is called
Instantaneous velocity.
instantaneous
Yeah.
velocity is. So delta t approaching 0 means we represent it like this. So limit delta t approaching 0, delta x upon delta t. For small changes, we represent dx by dt. For larger changes, we represent what? Use dx upon dt. For large change, use like this triangle delta x upon delta t. So the formulas which you are seeing so far, it's not like exactly dx by dt. In the short notes I have written like d for difference. That makes sense, right? So usually it is delta x upon delta t. I mean I didn't look out for the symbol. So I'll try to correct it. So usually for large changes, we consider delta x upon delta t. For small changes, dx upon dt. This is the approximation. Cool, right?
Yep. Is the I'm just checking, is the like comparison between the different types of graphs chapter 2 as well? Or is that next?
Was it there in the chapter 1?
Yeah, so there's like velocity versus time graph, acceleration, right?
Yeah, we'll discuss that. Okay.
Yeah.
So come to the next stage. We'll try to graphs. Okay, we'll talk about, let's say, velocity. Let's say a particle is moving with constant velocity. Constant velocity. See, v is equal to constant. This is also equal to, let's say, dx by dt. See, dx by dt is equal to constant means what? What happens when you integrate?
0.
When you differentiate, it will become 0. When you integrate, you have to write like this, c dt,
Oh, integrate. Yeah.
like this. So initial to final, initially it will be, let's say, time is 0. Finally, we count time as t. Okay. Do you understand this notation first?
Yeah.
Okay. So something like that. So integration dx will be how much?
It'll be the final minus initial. So you integrate using t and then minus.
Like this, right? Initial planning is equal to, what is this? C is the constant, correct?
Yeah.
So C comes out.
Yeah.
It will be now what? Integral dt will be how much?
So the 1 over t dt is
No, no, no. See, if nothing is mentioned, let's say 1 dt, it will be t.
t.
So C into this t, 0 to t. That is how we have written that. Dx means x.
Yeah.
One way, other way to look at it is integral and differentiation are opposite. So x will be remaining.
Yeah.
Integration nullifies the differentiation. So integration nullifies the differentiation. So t is left.
Mm-hmm.
Calculus. So xf minus xi, which is displacement, is equal to c into t.
Yeah.
For constant velocity. So if you are talking about, let's say, x versus t graph,
Mm-hmm.
can you guess what will be the, what do you say?
Should I just draw it? Velocity.
Yeah, what is the relation? X versus t.
Right. So as your position, as you're increasing in position, velocity is going up at a constant rate. So it would just be like a linear,
Yeah. So you have to write like this. See, y versus x, right? Yeah.
Position over time, right?
Yes. It's like y-axis and x-axis. So
Yeah.
on y-axis it should be x, as you have written, and on the x-axis it should be t. So it's like xf is equal to something into t plus xi. So y is equal to straight line, linear relation.
Yeah.
But it is not passing through origin. Notice this is not actually passing through origin. Passing through origin means y-intercept will be how much?
0.
So b should be 0. But here we have what? How much is the y-intercept?
It's not passing through anything, right? So,
Well, this is the formula which we got, correct?
yeah.
Y is equal to something into x plus b.
Yeah. Yeah.
Y-intercept is this b value.
Yeah, so it'll
xi.
just be the initial position.
So xi will be here or here?
Here, but
Yes, because it's on x-axis. I mean y-axis.
it's on the, that's where the position is that you're
Yes.
showing. Yeah.
So the graph starts from,
Any initial position.
so graph has to be like this, drawn like this.
Mm.
I mean this is the line, but negative t we don't consider.
Yeah.
The straight line is something like this. Since x-axis is t, we don't consider t negative.
Yeah.
So we look out from here like this.
Yeah.
So this is the portion we need to consider. So this is for constant velocity.
Yeah.
So let's talk about that still. Let's talk about acceleration.
Mm-hmm.
Okay, let's say for constant velocity,
Then you don't have acceleration. You're just going constant. So it would be
yes.
around the 0.
So y equal to 0 line. Is it a horizontal or vertical line? A
A
versus
versus
B.
T, right? So,
Yeah.
so time is passing, but acceleration is 0. So it's just going to be horizontal line, right?
Yeah, it's like y versus x, right? I mean y is equal to 0 into v. V is x.
Yeah.
A equal to 0. So y is equal to 0 means horizontal line or vertical line?
Horizontal.
Horizontal line. So x-axis basically.
Yeah.
Okay, this is about A versus V graph. Let's say V is. Let's talk about the main concept, which is about displacement. Come to the next page.
Because I remember doing this in AP Physics, and then I remember I was fine with it initially, and then as the graphs got more complicated, like just like that, then I would like lose like.
Okay.
I wouldn't.
No problem. We'll start from basics. So let's start from basics. First formula which we learned about was about velocity, dx upon dt.
Yeah.
Okay, I'll remove the arrow marks for now. So for convenience, I'm writing v and x. Okay,
Mm-hmm.
you get the idea, right?
Yeah.
So acceleration will be dv by dt, correct?
Yep.
But what is v? V is what actually?
But yeah, the rate of change of position.
Dx by dt. So it will be second order d2x upon dt square.
Mm.
Yeah. So let's talk about if acceleration is constant.
Hmm.
So we know that a is equal to d2x upon dt square, or d by dx of v, d by dt of v. So if acceleration is constant, a dt is equal to dv. So you take integration here. Can you write the limits? This limit and this limit. This.
Um, so acceleration is constant, right? So
See, the main player is dt. T is the variable here because differentiation is with respect to t. So we have to write the limits with respect to t. So t is equal to 0 initially. Let's say final journey, the time accumulates is t seconds.
yeah,
So in the beginning, let's say initial velocity, let's say v naught. Final velocity, let's say v.
yeah,
So a is a constant as we assumed.
yeah.
So it comes out. So a into t minus 0
Mm-hmm.
should be equal to what?
18.
Yeah, I mean on this side.
Just v.
So v limits are v naught to
Yeah.
v, right?
Mm.
So put v first and then v naught next. So v minus what?
Minus v.
V naught. So at is equal to v minus v naught. A is equal to v minus v naught upon t. Okay.
Yeah.
How will the graph of a versus v will be for constant acceleration?
Um. Okay, so acceleration is constant. Okay, so if acceleration is constant, then um,
So the y values should have to be the same throughout.
yeah,
So let's say this point, it will be a. For this point also it will be a. For this point also it will be a. So you get a horizontal line.
okay, but then
What happened? In the previous case, we assumed
it wouldn't be that.
what?
But if it was okay, so if it was acceleration versus time, it would also be the same. Like there's no difference. Like
Acceleration versus time. Let's talk about it. So a is equal to dv by dt. Okay, if you are assuming constant acceleration, we just got the formula v minus v naught upon t.
yeah,
So y is equal to some b by x, something upon x. This is y, this is x, right? So y equal to 1 by x graph will be how?
it's involved. It's rational, yeah. And then you're gonna have asymptote.
Like this.
Mm.
This is a y equal to 1 by x graph. But x was what here? On x axis, what we are representing?
The time.
Time. So we have to consider only this part, not this. So the graph of a versus t will be for constant acceleration like this. Okay. We'll talk about graphs more, but for now,
Yeah, I think.
I have
Okay.
extended the
Mm.
class. So